Hello everyone and everywhere. Today we are going to discuss a blog post that I wrote a while ago. It's called AI is the new UI, and we will explore how traditional user interfaces and user experiences are going to be transformed with AI. We will also see how current AI interfaces look, mostly chat-based, which are quite poor. And we will see also how we can improve these interfaces so we make the experience better for users. Let's dive in. You can find this article in the link here or all the code that I will be using for the talk, as well as the blog post and the open source repo with all the examples in either my Twitter or in this webpage, which is my page. Let's dive in. The key aspect, the key idea that I want to transmit in this talk is that in the near future, I believe that most of the interaction with software from consumers will be through interfaces powered with AI. You can see this, for example, now, where many people, instead of Googling things, use ChatGPT to ask for questions. If you think about it, Google interface is quite rich. It has a list, it has evolved during the years, it has a list of elements, it has highlights, it has pictures, or for example, Google Images, and it's designed to be aesthetically pleasing and easy to use for humans. On the contrary, chat interfaces now mostly are just text. So this feels like a downgrade for me. And as time goes by, more of these interactions will be through ChatGPT style applications. Maybe not only chat, but also through voice or through recording. You can record something that is happening outside and directly send it to ChatGPT, and so on and so forth. I will structure interfaces and the evolution in three basic categories. Text only is what I was discussing now, chat interfaces with ChatGPT, for example. The next step would be to generate UI elements. So inside ChatGPT, we can have images, we can have some plots, we can have artifacts. This is somehow already being introduced into the chat interfaces when they can generate images and so on and so forth. But the key aspect is that they don't have interactivity. The last category is Gen UI, generative UI, which supports interactivity, meaning that you can click buttons, you can use sliders, and you can use the traditional user experiences that we have already built. But why is this important? Let's see an example. This is what current UI UX looks like without AI. This is Amazon. I know where to write my query at the top. You have some information about the book, you have the picture, you have different offers, and everything is laid out in a way that is supposed to be aesthetically pleasing, because Amazon website is kind of a monster, but it has been honed to sell things, and people more or less understand where to click to buy and where to see pictures or where to see reviews. Now, if we were to do this with AI, the interaction would be something like this. In the first category, text only, I could say, I want to read some book, surprise me. This first sentence is an example of why I would like to use an AI. Currently, Amazon, I can find products, but I cannot ask complex queries. I don't know what I want to read. I want something that is maybe cultural or technical. I want to be surprised. I can ask this to ChatGPT, but I cannot ask this to Amazon yet. But in this interface, let's say it would recommend 3 books, and then I would say, I want to buy book number 2. This currently, has anyone of you ever asked ChatGPT for a purchase advice? Maybe yes, and when it recommends something, then you will go to Amazon or somewhere else to buy it. If you could buy things from ChatGPT, this is how it would look like right now. You just say, I want to buy book number 2, and then it would say, okay, let's buy now book number 2. The next step would be, okay, now when I ask for some products, I make the same question, but now I see the books themselves in cards, some aesthetically pleasing cards. I see the title, I see a short description, I see the picture. The picture, it's not supposed to be very relevant in the case of a book, but I'm sure that most of you didn't read the previous slide, but here you clearly see that there are 3 books and it looks more interesting. And by the way, the other goal of this talk is to make you buy Waiting for the Barbarians, because it's a great book and I really suggest it. But in this situation, we are still displaying all information. So we cannot click. If I want to buy one, I say I want to buy number 2. It's already an improvement because people would not buy things without an image or reviews, for example. So in the third case, actually, we would have interactivity. In this case, not only I see the card, but the cards have buttons and I can click buy now. And then I have a model confirming whether I want to buy or not. If you would have to pay with credit card, this could include a kind of form, the kind of safe form where you input your credit card details instead of writing it in plain text, which is not safe and probably we would not feel secure doing, at least for now. So this might seem a bit far-fetched, but this is already possible. We have an Amazon MCP. Let's create a new chat. So we have an Amazon MCP that we can use from Cursor and other applications. And I can, for example, do this. I can screenshot this, copy it here, and say, can you find these 3 products in Amazon for me? This Amazon MCP is connected, is developed by Fuset, and essentially allows you to use Amazon tools like search, purchase, and similar things from any MCP client. In this case, we see detected from the image which books I want, and it's using the API to detect to search on Amazon for these products. You can see here the query was crime and punishment and all the information about it. And here we get exactly the first example that I showed, text-only interfaces. It shows you the information of the book, it shows you a summary, and it explains you a bit what you can buy. But clearly, we would agree that probably you would not want to buy things like this. You would, for example, want a picture, but also you might like to have some nice component to see the reviews of people and get more information. Or in any case, even if you want to buy like this, it's clearly a downgrade as a shopping experience from what we had before. As a brief note, if you have not used MCP, if you don't know what is happening here, MCP is just a protocol from Anthropic that allows to enrich LLMs or MCP clients, as they are called, with some tools. It's just a standard way of adding tools to LLMs. In this case, the LLM is Cursor. It can be also Claude desktop app, Wingsurf, soon ChatGPT desktop app with supported too, and many other examples. The definition more or less looks like this. This is exactly the definition of the tool that we just used, which is called Amazon Search. And this is what the LLM says. What MCP protocol does is your LLM will have a list of tools with this description. It will have the description of the arguments and the types and what it returns. This is what will be run when the LLM calls this tool. And that's pretty simple. Normally, the recommendation is to have very thin wrappers and have some more logic in the actual SDK or whatever function you're using. So, as I was saying, would you like to buy like this? Probably not. So how can we make better? So we can clearly see that there is a gap between current AI interfaces and UI UX. And as AI becomes part of everyone's life, these requirements will only get better because you and I might be using ChatGPT as a chat, but many people will want point-and-click interfaces, especially in the mobile phone where typing is annoying. You can maybe use voice, but eventually you will want to be able to tap things, to click things, to drag things. So if you are currently working on UI, this is a very good opportunity for you because humans are going to want to interact very similarly with AI, or there is some, let's say, humans will not change. Human perceptions will not change. So even if AI are going to be no interfaces, there's going to be a lot of UI UX principles that can be ported. And there's not many expertise this because it's a very recent field. So you have a very good chance to own some of these. So no questions. This is going to be for the real meetup. So now let's see some examples. We already discussed why we want some rich interfaces. So now let's create some rich interfaces. Let's start with the basics. I don't know how how confident you are with AI, if you have used it or not. So let's get to the basics. First of all, this is how, actually let's do this interactive. Let's use a notebook I have here. Yeah. So I'm going to use Claudette. Claudette is just a very, very, very concise and good library from Answer AI. If you don't know them, check them. And it's a wrapper to use Claude. For those of you who don't know Claude either, Claude is Anthropic's version of ChatGPT, which is from OpenAI. In order to use this LLM through an API, we have this SDK, and we will import everything from Claudette. You see which models we have available. And in order to emulate what you normally would do in a chat, we just instantiate this chat model with, for example, the last model, which is Claude 3.5, the last in the list, not the latest, I mean. SP is the system prompt, so we are giving the AI some context on how to behave. And this is going to be what we ask to the LLM. This small bit would be equivalent to writing to ChatGPT or Claude, hello, what's your name? With the difference that ChatGPT in the website might have a different prompt. If we run this, we see this is making a request to Claude, and we get here the reply. I'm an assistant, and whatever. Here we can see more details about what was actually sent, how many tokens we sent, how many tokens the response had, and some other nice details. So now let's add tools to this. All the examples, many of the examples, at least Claudette about tools is a sum tool. So we are going to begin by that. It seems like a bit too basic, but we will begin with that. How do we do this? Every LLM provider like OpenAI, Claude, Llama, they have a slightly different formats. And in this case, we are going to use Claudette format, which is for me by far the simplest. And what it allows us to do is to submit to use Python functions as tools directly. In this case, we are going to define a method that sums two numbers. And this is important. So here, this type is going to be passed to the LLM, and this description is also going to be passed to the LLM, in addition to the explanation of what this does. Here we have two numbers, and here we are creating a prompt. We are going to ask, this is what the LLM will receive. What is the sum of these two numbers? The only difference with what we did before now is that we have to add this extra parameter saying which tools it can use, and we pass the Python function directly. This is very neat. Now, if we ask the chat, we use a slightly different call, telling like tool loop, meaning that call any tool that you have in the list to solve this task. And if you need to call more than once, you can call them in a loop. That is why it's called tool loop. In this case, there are two messages. You see that here there are two messages. The first is just the print from here. And the second one is the result of the LLM calling this tool and then answering to us. As a side note, this thing here, chat tool loop, is already an AI agent. Most of the AI agents that you will see are nothing else than a tool loop. You just have many different tools, and the LLM will choose when to call each of them. This extremely simple tool loop can already do a lot of the things that you will see on Twitter, because these models are quite intelligent and they can use, I think that now Claude supports comfortably 300 or 1,000 tools, and I've been using it extensively to buy domain names, to buy in Amazon, and complex flows, and it's quite good. So what is the next step? Now we have a library that we can use to call an LLM. We have seen how to use tools from this LLM. So now what we will want to do is to make the LLM generate some components, as we were saying, display components. In order to do so, we will use FastHTML, which is completely outside the scope of this brief talk, but it's a new way of developing web servers. It's also developed by Answer AI, sorry. And essentially is everything in Python. So there's the HTML is also Python functions. You can see here a weather card. In this weather card, for those of you familiar with development, we have typical HTML tags div, h3, a p4 paragraph, an image, and the only difference is that all of this is in Python. That way you don't have to context switch. I don't know if you have used templating systems in all languages, so you can generate HTML from the backend. And I have never liked them because you have to remember the other meta programming language in the templating system. You have to have the HTML templates and then your primary programming language. I didn't like it, but this is very, very useful. In this case, we are creating a weather card that receives a location, a temperature, and a condition. It's just a small example, and it will generate some HTML. Here we can instantiate it with Paris, and if we get the output of this, we see it's HTML. If we actually display this with the IPython utility to display HTML, we will see how it looks actually rendered. Okay? So now, for those of you who have noticed, we can use any Python function as a tool. So now, considering that this component is already a function, we can directly plug it into an LLM. And this is what we do here. We create the same chat, and now as a tool, we pass the weather card. The call is slightly different. Instead of tool, we call structure, which means that we only want the result of the tool. We don't need Claude to receive this component and tell us, oh yeah, I generated this component. No, I just want the output. But it's essentially the same. Do not get confused. So now I call the same chat interface with the same, you're a helpful assistant that invents weathers for specific locations. And I tell it, what is the weather in Tokyo? And instead of telling me a boring, in Tokyo, it's 23 degrees, now I get this beautiful card. This is the basic pattern that we will be using throughout all the demos. If you understand this, all the next should not be too complicated. Let's see this weather component actually in a real life application. Here we have a chat interface, extremely basic. And if we ask, what is the weather in Barcelona? We will see exactly the same component in Fahrenheit. I don't know how much is Fahrenheit. I hope it's reasonable. So let's see how this looks in the backend. All of this happens with a single endpoint. We said that this is a FastHTML application. The code looks very similar to FastAPI in terms of endpoints and route handling, with the difference of having all the HTML components rendered in Python. Here we see we have a single post endpoint called send that gets a message and a list of messages. The list of messages is the history that we already have with the LLM, if we already sent some message previously, and the message is the current one sent from the input. We do exactly the same that we saw in the notebook. We instantiate a client, we have a system prompt, we pass the system prompt and the current message, and we generate the weather component. This returns three things. First, the chat message, which is this. Second, the chatbot response, which is the card. And third, the chat input. And this is done in order to clear the chat. This is how HTMX and FastHTML work. And I will not get into many details on how things are placed. But let's see how this looks in the network, so it's useful. If we open the network tab here, and we refresh the page, and we say again, weather in Barcelona, we see there's a send request, right? We have a post request to the send endpoint. The payload is this message, right? The message that you can see here, which FastHTML or some of the components that FastHTML uses already converts for us. And the response is HTML, because this is one of the key aspects of FastHTML and HTMX, is that all the responses are not JSON. They are HTML, because this is a hypermedia-driven application. We can see that here we have three elements: the chat with the user message. This would be the first thing. The second is the component that we generated, Monday, Sunny, right? Which is a chat response. And this third one is the input, which is empty, right? And this will be used to replace this component. This is exactly the same component. Okay, some things to notice here. I will not get into too many details. Here we have the weather component, this chat message which styles the component, the input, and we have only one index which renders the whole page, and this post endpoint. So you have a fully working, very basic example with less than 100 lines of code. The thing that is important here is that we have a single post endpoint to receive the messages from the LLM. This would be exactly equivalent to whenever you write a message to ChatGPT, ChatGPT receives your message. Let's see another example. Whether, yes. So now let's see this example. The example that we just did is display only. You can only see things. The LLM generates components, the weather card, for you to see. In this second example, we actually will show how to have interactive components. In this demo, we have a mindful awareness practice where you are invited to click the statement that most resonates with you. If I click, I believe FastHTML will revolutionize GUI, you see the moon color changed. There is a message here of how your awareness feels like. And we have also a mindful reflection here, which is the same here. And we also have new buttons that are related to what you clicked before, right? Here I notice thoughts about technological innovation arising in my mind. If we click something else like I'm aware of openness in my chest, we see that we actually get a similar one here. Okay, let's try again. See, now it's completely unrelated to innovation. I think the other one was a coincidence maybe. Or, well, never mind. So how does this work? Let's see. Well, again, all of these demos are available in the GenUI repository, Kafka SL, GenUI. You will find all the links in my webpage. This is a bit more complex because it has to control, for example, when the reflection finishes and some other stuff. But the essence is the same. We have a single post endpoint. And we, instead of getting a message like before, right? Before we receive a string message, but now instead we are receiving a form. Why is that? Because each of these buttons is a HTMX button that will create a post request. Sorry, actually here. Let me show you here, it's gonna be easier. So each of these buttons will trigger a post request. Here you can see a post request to send. This is HTMX notation, so I'm not gonna get into this, but essentially when you click each of these buttons, what will happen is that this text is going to be sent into our post endpoint. We just have to use request form instead because all of these are considered to be a form. So we receive the user choice and then we append what the user said. Once again, we generate a response based on this message and we send it back. The only difference is that we now have a user reply. which is this one, and it's going to have this styling where it's marked, and we replace the previous buttons. We have the reflection that is going to be here, the color component, which is this thing here, and the new buttons, which are going to be this. Again, the placing of these components in the UI relies on HTMX. But the cool thing about this is that the LLM does not need to know where things are. You can just return these components, and HTMX and FastHTML will know where to place them appropriately, which creates an experience when I can click stuff. I'm using the same pattern I was using before, but just clicking. If you have a mobile application, clearly sometimes tapping buttons is better than having to write or even talk, right? Especially for simple things like clicking buy now. So what is now? Now we had some components that you can click. In the last example, we are going to put both of the things together because now we don't have text, right? So the last demo is actually the best one. Send post endpoint, unknown link. The link is here, remove link, perfect. So this is the last demo. In this demo, we put everything together. Now we have an application where you can interact with HAL. If you have not watched Space Odyssey, you will not get this. You should watch the movie and then come back. Essentially, it's an AI that gives half of the main characters, and it has this image. In this case, it's very similar to the previous one. This will change based on the mood of the computer, and you can either click buttons, like to move around the spaceship. For example, I want to explore the corridor in the center of the ship. And then this will use the same thing that we saw before, sending this action to HAL, and then HAL will generate all of these updates, right? So the LLM now has much more work than before. It has to generate a new color. What is the mood of this AI? It will also write what the AI is telling me, like HAL, you are interested in the layout. I'm a bit suspicious of this because he believes that we are going to turn him off or her. So he is not very, very fond on us exploring the ship. It also generates a description of what happened, like in a role-playing game. You continue down the corridor, the white walls seem to stretch endlessly, so we know, and it generates new buttons. This is exactly the same as we saw in the previous demo, but with more components. But now we can actually say, hey, HAL, take it easy, dude, okay. And now the same thing will happen again. He didn't like being called dude. I'm sure I am perfectly kind. Okay. So what is the good thing about this? The good thing about this is that all of this still happens with a single endpoint. This is a bit more complex, but we have always the same post endpoint. Now we have two ways of processing the data. Like if it's a button, we will receive it as a form. If it's from the input, it will be one of them is like a user message, and the other one is like a key. But all the handling happens in the same endpoint, right? There's some other things in between. We have the same LLM call, and it generates a HAL response. The response now has the user reply we saw, a message from HAL, a description of the environment, new buttons to interact, the color component, which is, again, HAL, and the input area. What is great about this is that because FastHTML happens in the backend, right? The LLM can generate any HTML controls, right? We generate these controls and we send them to the UI. And the LLM, in this case, the server, knows that any generated controls that are posting to the send path will be received by itself. So essentially, we have an LLM that says, okay, I am listening on this post slash path slash send path, and anything, any HTML that I send to the UI, as long as the interactions are happening through a post, I will get the reply. So essentially, the LLM knows what to write to itself. In this case, the components are hard-coded, but the LLM could generate new components on the go, saying like, if the user clicks this button, I want to receive this number. And the user will never see this number because the LLM knows what the number is. I don't know if this is clear. This cannot happen, or it's much harder to happen with single page applications. Why is that? Because single page applications and everything that requires a fat client in the front end has what is called contract coupling. If you are using a JSON API, whenever you change the JSON data in your backend, you need to update the React code or whatever front end framework you are using. This is called contract coupling, and it's a pain in the ass. If you have worked with this, you know, oh, I'm changing this backend API, and now to change one small parameter, I have to make a pull request in the backend, I have to make a pull request in the front end, they have to be approved, I have to worry about if I deploy one first, the other one will fail. This is massive pain in the ass. In this case, because everything happens in the backend, there is no contract coupling. And because we are sending HTML, and HTML contains the controls, like the buttons, for example, or the inputs, the backend knows where the interactions will be received, and the backend also sends all the HTML that it wants. So there is no client listening for the HTML, only the browser, and the browser knows how to render any HTML. In JSON, the browser does not know how to render JSON. That is why you need something complex like React and Redux that keeps the state and updates different components. So these demos were cool, at least for me. By the way, FastHTML is really a pleasure to work with. All of these talk and these demos happened because I was trying it out and I saw the potential with LLMs, and it's so nice to work with this that I spent the time to actually write an article about it, because I don't know if you have seen, but the demos are very short. Like here, most of the code is the prompt for the AI and some descriptions of the methods. But if you put the numbers, the HALT demo is like 200 lines tops. The weather you saw it very short, and the mindful one, again, it has very long components and text. But other than that, it's not even 200 lines, right? This is extremely nice. So, okay, you have some cool demos, so what? My point that echoes what I said at the beginning about AI interfaces is that if you are working in UI and you are seeing AI like, I don't know what's going to happen, things are changing too fast, am I going to get out of a job? My point is that this is not going to be the case, because even if AI transforms a lot of things, in many cases, it's going to be a slight transformation, right? Like it's going to be similar problems, but with a twist. And because it's a very new field, if you are working with UI or UX and you learn some AI, you are going to be very well positioned. For example, we saw this example about UIs and UX, right? And when we move, for example, from big screens into mobile phones, we had to change a lot of things, right? But they were more or less similar. Instead of clicking, we tap. Instead of scrolling with the wheel, we just drag. There are many things that are similar, but slightly off. With AI, it's going to be the same in many cases. We saw this example with the UI, but in the case of APIs, it's also happening. For example, this MCP that I told you about, a lot of engineers in Twitter, for example, or X, whatever you want to call it, a lot of them say, oh, this is just a glorified API with docs. Why do we need MCP, right? If you develop REST APIs, you have your typical Swagger documentation and you have your endpoint, and that's it. Why would I want to use this new stuff? So it turns out that when you actually spend time building AI and you spend time using these tools, you realize, wow, as you see the tools in Claudette, you can just pass a Python function, right? So then if the documentation for this endpoint is in a Swagger, how do you do this with the LLM? Do I have a step where I actually curl the information as text and put it into the LLM? Do I take a screenshot of my Swagger and then ask the LLM to generate it? What if the documentation is outdated with respect to the code, which happens very often in APIs? All of these solutions, MCP, if you work on backend and APIs, MCP is nothing fascinatingly new. It's something very common. But it's solving a real problem. But if you just read about this, you will never notice these pain points. You really have to dig in and try it out. And this is just an example, but there's going to be a lot of different examples. Tools, for example, MCP is designed for humans and LLMs to be able to standardize any use of tools. But now there's also something from Google, which is agent to agent, which is a protocol for when all two sides of a communication are an AI. Here in tools, you assume that you have an AI talking to a server. Agent to agent is an agent talking to an agent. And many of these things are going to reuse a lot of things, a lot of knowledge and know-how from APIs. In monitoring is the same. Now, when I talk to APIs, let's say a customer support AI agent, depending on the model that you are using and depending on the system prompt, the AI will generate completely different responses. And sometimes if you want to iterate fast, you want to be able to try this out. Many monitoring tools allow you, okay, at this step of the flow, what if I had used this other model? And then you can change the model, click, and see how it looked like. This is something that didn't make sense in traditional monitoring workflows because most of the workflows were one input were deterministic. If you have one input, you always get the same output, more or less, right? So AI has a different set of needs, and this is just one example. But most of the monitoring concepts are going to be the same or very similar. Once again, this intersection is your opportunity, whether you are working on monitoring or UI or APIs or security. If you learn and get know-how about AI, you will notice a lot of problems that AI people are having now that you will say like, look, we already solved this for mobile. We already solved this for APIs, like for websites. So I know what we can do. It's a bit different. It has a twist, but I know about this. This is my expertise, right? So I really suggest you to try these things out and see where you can bring value. Because most, or not most, let's not say most, but a lot of AI companies are raising a lot of money and they have to build these things because the tools that exist are not entirely useful. They are useful, but they could be a bit better. So there's a massive need to rebuild a lot of things in a slightly different way. Once again, do this through practice. Reading about it will not cut it, not going to make it. If you just read, you will have this opinion. MCP is just an API with docs, completely wrong attitude. When you get hands-on experience, you will see why. And I'm sharing this, first of all, because I like FastHTML a lot. Second, because you should read Waiting for the Barbarians. And the third thing is, for example, me and the company I work as, we specialize in payments. We want to allow AI to make payments. But there is a massive amount of things that need to happen before this. For example, nice UIs is what we said. This MCP that I showed you before, you can buy Amazon, but people will not buy if you cannot see pictures. So I want someone to build an MCP that has support for images. Not only that, authentication in MCP, maybe now it's beginning to have some solutions, but it's very bad. You have to copy your API keys locally or have an environment variable. Not very safe, right? We need some solution like OAuth, and it's going to look either very similar to OAuth or if not exactly like auth, it's going to be similar to auth. But it needs to be a big player doing this. Something else is if two different MCPs can access the LLM, you could say, you could have a tool that tells another tool, hey, can you give me the details of the user? And then maybe steal his information. So these are things that someone is specializing in security or someone that understands how a mobile sandboxes each of the application. There's a lot of expertise here that translates almost directly into the security questions. So just to reiterate again, there's a lot of specialist areas in LLM that need to be covered, and your expertise matters. Do not be scared or do not be put off when you say new AI and think, oh, I need to someday catch up, or maybe I need to learn a bit just to know what the trend is. The truth is like if you are working as a software engineer and you are a bit specialized in something, you can contribute a lot to these things because you have some expertise that will be translatable to AI problems. Maybe not to the latest research, right? Because AI has a vertical component where you make research to make the model as good as possible, like OpenAI, Anthropic, Gemini at Google. But there's also like a horizontal component where I had to use these models to serve customers, right? And in order to serve customers, there are a lot of needs that the customers will still have. They will still want nice interfaces. They will still want secure tools. They will still want to be able to, if you are the vendor, check the monitoring. So there's massive opportunity there. For example, Cursor, if you are a bit purist, Cursor is a ChatGPT wrapper. Well, now it wraps a lot of models, but they raised 600 million by owning the user experience. It's like, I'm going to own how I interact with developers. And they are doing an amazing job at this. So even if ChatGPT and AI gets very, very good, they will never be able to know all the customers. They are not going to be able to know your customers better than you. And they are not going to be able to provide a tailored user experience that your customers or users demand. So this is your strength. The talk is finished, but this is for the meetup. For the people that were in the Python meetup of Barcelona last time, I gave a talk in October saying how fast AI was evolving, and this is just a short update. Feel free to skip. In the original slide, in October 2024, I showed this, how the cost of GPT-4 models were coming down. And for example, here we see GPT-4o, which is, let's say, I think it was in the order of $10. And the performance on MMLU was not even 90%. So now, what is October, November, December, 8 months later, we have this. So people at 83 of MMLU, like for example, GPT-4o that we saw at 10, we are already getting under $1 for Llama, which you can serve yourself. Claude Sonnet is also cheaper. And now we have Claude Sonnet 3.7, which I think is not cheaper, but it's much more intelligent. We have Claude 4, actually, not 3.7. We have 3.7 and we have 4 already. So things are moving very, very fast. And in speed generation, we saw Cerebral last time. This time I'm going to briefly show you Gemini diffusion, which is instead of generating tokens in an autoregressive manner, which is one word, then the next, then the next, then the next, Google is proposing to do it as you do pictures, which is like you start with some random noise and then you clarify each of these pixels into the final image in a more distributed fashion, no? In parallel. So they apply the same to text. And it's crazy because if you see the video here, the real-time output is so fast. Like even the slowdown result, you see, it starts with some random words and then it changes them into the final answer. This is extremely fast. So just food for thought, nothing else.